Welcome to 2.4. This is medians, midsegments, and altitudes, as well as perpendicular bisectors and angle bisectors. We're going to start with what a midsegment is. A midsegment is a segment connecting the two midpoints of a triangle. So the idea is it goes right through the middle of the triangle. What's special about it is the midsegment is half the size of the base. So if the base is 24, then our midsegment is 12. So if our midsegment is 6, it's half the size of the base, then the base is therefore 12. So the idea is that, again, the midsegment is half the size of the base. So we multiply the midsegment by 2. So 2 times x plus 18 equals x plus 26. So we get 2x plus 36. Subtract x from both sides, we get x. Subtract 26, or subtract 36. And you get negative 10. So x equals negative 10 here. A median connects from a vertex to the midpoint of the opposite side. So the midsegment cuts through the middle of the triangle. The median cuts the triangle almost in half. What's special about a median is that it cuts the segment in half. So JC and HC are the same. So if I know that JH, the whole thing is 20, then one of the halves is just 10. Here ET, one of the halves is 11. It wants to know how big is the whole thing, so it's 22. FQ is a half. FS is also a half. Those two halves are just equal. So x minus 1 equals 2x minus 9. Subtract x, you get x. Add 9, you get 8. Here we have XW, which is the whole thing, and RW, which is half. So we're going to double the half, so we have RW twice. So x plus x equals x plus 11, or 2x equals x plus 11. Subtract x and you get 11 for x. It wanted to know how big is the whole thing. 11 plus 11 is 22. An altitude goes from the vertex and is perpendicular to the opposite side, meaning it creates a right angle. In an acute triangle, it's inside of the triangle. On an obtuse triangle, it's more often than not outside of the triangle. And on a right triangle, it's part of the triangle. So the idea with an altitude is perpendicular, meaning it's 90 degrees. So here x is 90. So here we set 3x plus 9 equal to 90. Subtract 9, we get 81. Divide by 3, we get 27. Next one is a perpendicular bisector. It cuts the segment in half as well as making it perpendicular, so 90-degree angle. So this one's asking how big is the angle. It's just 90. So 4x minus 30 is the angle, equals 90, plus 30. You get 120. Divide by 4, you get 30. Here we're talking about sides. It wants to know how big is the whole thing if one of the halves is 5, so the whole thing is 10. This time we know the two segments are equal. X plus 36 equals 3x plus 6. Subtract x, you get 2x. Subtract 6, you get 30. X equals 15. Wants to know how big is AB. So we substitute 15 in. 15 plus 36. And then we double that to get the whole thing, which is 102. Last one is angle bisector. It's cutting the angle in half. So angle 1 and angle 2 are always equal. So here angle 2 is 21, so angle 1 is 21. It's telling us this one, FDE, is the whole angle. The whole angle is 64, so one of the halves is just 32. In this one, it's telling us angle 2 and angle 1. We know that angle 2 and angle 1 are the same, so we set them equal. 5x minus 1 equals 4x plus 9. Subtract 4x, you get x. Add 1, you get 10. Our last example here, it tells us angle 1 is 2x plus 11. It tells us the whole angle is 5x plus 14. So we double angle 1. So we get 2 times 2x plus 11 equals 5x plus 14. We multiply by 2, we get 4x plus 22. Subtract 4x from both sides, we get x. Subtract 14, and we get 8. It asked us how big is angle 1. So we do 2 times 8 plus 11 to get that angle 1 is 27. Right, so that is our special segments. Good luck with practice.